Projections suitable for mapping the world are not necessarily the best for mapping smaller areas, such as continents or countries. When mapping at such a scale in the mid-latitudes, it's important to use a projection that centers on the area being mapped and has a standard line or lines passing through the area being mapped. In this task, we're going to look at a map of the contiguous United States using a few different projections. So here I've got QGIS Desktop open with the country view QGIS map file open. This is an unprojected map of the lower 48 states comprised of three themes: the United States, the LA and New York city points, and a circle. You can see this circle doesn't look quite right given the default projection. It shows some obvious skewing. The distance property is more difficult to judge though. The known distance between LA and New York is approximately 3962 kilometers as the crow flies. So let's see how the unprojected map controls for distance distortion. So I'll use the measure tool for measuring line, and I'll measure this distance from LA to New York. And I get 3928, just about right. So the measured distance is virtually the same as the actual distance between these two cities. So remember, for this projection in QGIS, coordinates are treated as spherical latitude and longitude. Distance is calculated as if along a great circle arc, and so the actual ground distance is preserved. Shape and area properties, however, are distorted. So now let's change the CRS, or the projection, to Eckert 4. I'll close my distance units, and I'm going to go to the project properties. Since I used Eckert 4 in the last task, you'll see that you have a list of recently used coordinate reference systems. So one way to find them is obviously using the filter, but you can also use recently used coordinate systems. I'm going to choose Eckert 4 from that list and click OK. There's clearly a great deal of distortion using this projection, most obviously the shearing. Part of the problem lies in the fact that this projection is centered at 0 degrees longitude, which is Greenwich, England, far east of our study area in the lower 48. So let's center this projection on the United States by creating a custom version of the World Eckert 4 projection. So to do this, I'll go to Settings, Custom CRS. The Custom Coordinate Reference System definition window will open. I'm going to click this Copy Existing CRS button. This opens the Coordinate Reference System selector, and I'll select Eckert 4 from the recently used CRS list and click OK. You can see the parameters for this Eckert projection have been populated from those present in that Eckert 4 definition. Now I need to change the central meridian so that the projection is centered at -96 degrees longitude instead of 0 at the prime meridian. This will center the projection down the middle of the country. To do this, I'll find my longitude value here, and I'm going to replace the 0 with a -96. In the name box up here, I'm going to give it my own custom name. USA Eckert 4, and I'll click OK. So now let's put our map in our new custom projection. I'll go to Project Properties, and if I scroll down in this list, at the bottom I'll see User-Defined Coordinate Systems. I'll expand that, and there's my USA Eckert 4, and I'll click OK. So this is certainly a distinct improvement in shape, but there's still some skewing. The Eckert 4 projection is primarily used for mapping the entire world. So for mapping large countries at mid-latitudes, such as the US, other projections are more appropriate. The Lambert-Azimuthal, Albers equal area, and Lambert conformal conic are all examples of suitable projections for mapping the entire US. Because it has two standard parallels, the Albers equal area projection is particularly good for larger countries with a significant east-west extent like the US. So let's try Albers on our map. I'll go back to the project properties, and here I'm going to search by EPSG code, and for this projection it's 102003. I'm going to find USA contiguous Albers equal area conic, and I'll click OK, and I'll zoom in to I can see the map a little better. So this Albers conic projection has low scale distortion for an area the size of the US. As the area being mapped decreases in size, distortion is less of an issue. But this is really one of the projections that's used for the lower 48, and it's how we're used to seeing the lower 48. And Lambert would look very similar to this. There are many ways that we can customize a CRS. Any of those parameters that we saw can be customized. And you saw it only took a few seconds to create a new version of a CRS from an existing one. Often you'll customize a projection so that it's centered on the area in question, in this case the United States, simply by redefining the particular cartographic settings, such as the central meridian, the standard parallels, the reference latitude, or false eastings and northings. The choice of which parameters to change depends on which projection is being used. In Task 4, we'll explore state map projections.